Hi, welcome to the second lesson about virtual environments and devices. Last week we talked in general about VR. We say that the virtual environment, our senses are controlled and augmented by a computer, while our action influence to produce stimuli. So, for example, when you are turning your head, the picture is changing the perspective. This week we look at system types and applications. In the corner you see again the picture of NASA. This time it's a drawing, but you can see she's still immersed. So system types and applications. Note that developing and maintaining a VR system is a difficult task. In-depth knowledge in many different disciplines are necessary, so like tracking and sensing and stereo, computer graphics and also psychology. Here you see the many relations VR can have with other disciplines. First, it's good to notice that a VR environment is like a paper or television, a medium. With this medium you can inform, manipulate, train, influence people. And second, it's an enabling technology in the sense that it helps or powers other disciplines. But as you can see in this figure, VR needs other sciences, and other sciences need VR. More circles are possible, of course. Some relations focus on visualization with some interaction, and others are for the presence effect, where immersion is most important, like here with the circle with psychology. Some potential advantages of VR. As you enter an image, what you do in a virtual environment, you become a part of the virtual world. That is of course more compelling, expressive and comprehensible than just viewing a picture. You get an extra dimension. You are in a lifelike and life-size world, like reality. For example, in the entertainment domain, of course, it's clear an important fact of VR. An immersive environment is more vivid, more exciting and more attractive than just a film or only a mechanical roller coaster without VR. So, major use of virtual reality environments is found in the entertainment market. This is in fact the biggest application in terms of financial profitability. Many companies are producing games that use virtual reality principles. The audience for such games is enormous, and explains why this application is so important. Also theme parks and movies. But in this minor we look at different applications for VR. VR can do much more. Think about teaching, training and practice in a wide range of fields, and that users are allowed to experience situations that are impossible in the real world. By training, think about operators training, training of devices used, but also a training of procedures, like they do at the fire brigade. So here you see some potential advantages of VR. In the market, the business customers can get a VR presentation or maybe a VR experience instead of a PowerPoint presentation. Exploring data, so data visualization of complex phenomena. Data can become more clear, expressive and comprehensible with extra dimension and interaction. Art, it's a new tool for art form. Painting in 3D, it's like sculpturing. You see here a picture of it. Artists can explore ideas to communicate, to model and to design art objects or for architecture. Important also are the possibilities of VR to preserve our cultural heritage for the future. For example, digitizing objects and put them in the VR world, so that people can interact and experience the cultural world works in a way they never experienced before. They did something like that in the museum in Gouda, so let's look at it.
Traditionally, this is the way art has been displayed. A museum puts it on view on the wall or behind glass with a stern warning, do not touch. But in the Netherlands, Patricia Olstern, a project manager at the Museum Gouda, is reworking that concept with cutting-edge technology.
You can virtually pick the objects up and use them and look at them and, well, do whatever you like.
Olstern wanted a way for patrons to interact with artifacts. Now, practically playing with a one-of-a-kind piece of art was, of course, out of the question. So the museum partnered with Personal Space Technologies, a Dutch company, to design a high-tech 3D solution. PST brought in another company, IntraCAD, to make digital images of many of the museum's holdings.
We're liberating art. We're providing a means for art to be shared with others in a new way. That which is found in a museum is usually very nicely, neatly put for viewing. But let's say you want to pick it up and you want to view it, you want to see who made it. For instance, a vase may have something on the other side that may reveal something about its origin.
Once digitized, a display created by Personal Space Technologies projects the scan like a hologram via a 3D monitor. The user holds a wooden block with reflective dots, which signals the scan to move as the block moves, so the viewer can manipulate the artifact from every angle, even close up.
It's a new visual medium. It provides a new way of looking at things. A photograph, for instance, which is a two-dimensional picture, can now be seen from all sides. So it gives a new way of looking at things.
People can interact with our collection.
And everything known about the art object can be displayed on screen as well, so most questions can be answered with a touch or a click. Crumbling artwork can be held for display years after the original has disintegrated. And not only displayed art makes it into the exhibit.
There are a lot of things that can be scanned and a lot of interesting things that we want to scan. We're liberating art. That which is maybe in storage for various reasons can now be scanned in, can now be put onto a database, and if you visit the website in the future, you'll just be able to look it up and view it in 3D.
The exhibit, appropriately called Gotcha, or Hebus in Dutch, currently has over 35 unique works of art on digital display.
The visitors, they think it's fantastic. They've never done it before.
Museum Gouda believes the knowledge gained in this pilot project will help refine the 3D scanning process as they seek to give patrons greater access to their virtual collection. Bob Winstead, CNN.
We have this device also in our lab, so you can use it with your practical work. The same idea is possible for historical places. Here we see Rome. It's ancient Rome, and it's preserved by making models of the ancient Rome, and it's put in a virtual environment. So what if scenarios? Because we work with a computer program, we can try all kinds of scenarios with different parameters and see what happens. It's very important, I think, this possibility of VR for training, but also to predict some consequences of actions. Here you see Tom Cruise in the film Minority Report. This film has a lot of VR in it. Holographic projection, gestural interfaces with gloves. He can pick things up and resize them. And also a brainwave monitor as well, and complex interactive image display system he uses here. In the film, some creatures can predict a few minutes in the future, and in that way crimes can prevent it. And more nice examples. Quality of life. People with dementia in a nursing home in this picture. They get the sun and beach and sit with bare feet in the sand, and they seem to be relaxed and happy. There's not much technology involved in this world, this virtual world, but it can be extended. Furthermore, it's also possible with other mentally disabled people. Here you see an example of a wine workers application made in Australia. It's sold to China, Mine workers are trained with this VR application. They are trained how to react in a calamity or a disaster. In China often many mine accidents occur, so they want to use the Australian application to train their people. So less accidents will occur over there. So let's look at this video. A little bit bigger.
The University of New South Wales, in collaboration with Coal Services Proprietary Limited, is working to improve safety training in the coal mining industry. A research team in the School of Mining Engineering is developing virtual reality training simulations of mine environments where trainees can recognise hazards, observe possible consequences, and interactively correct them as a group. The University of New South Wales Coal Services Mine Training Simulation Project began in 1999 with the development of a flat-screen proof-of-concept system. 3 basic simulations were deployed and used daily at the Newcastle Mines Rescue Station in Argerton to train mine personnel. In March 2005, a new facility was commissioned for the Newcastle Mines Rescue Station, which included an immersive curved screen theatre and 3 refined simulations. The simulations, based on core competencies, confront miners with high-fidelity representations of the real-world problems and dangers of a dynamic, hostile mine site. The theatre allows personnel to experience and respond to these hazards in a safe and forgiving environment before actually encountering them in the workplace. The theatre was opened in September 2006 by Premier Maurice Yemmer and is used daily to educate and assess trainees in truck and shovel operations, rib and roof stability, and unaided self-escape. In late 2006, the team began a collaboration with iCinema, the University of New South Wales Interactive Cinema Research Centre, to adapt the simulations to their 360-degree immersive theatre. Stereoscopic glasses allow the simulations to be seen in 3D, and the cylindrical panoramic screen projection allows a group of miners to experience the simulations in an incredible degree of realism. The team has also worked with iCinema to develop an off-highway truck simulation in their hemispherical iDome system. The screen wraps around and fills a trainee's peripheral vision, allowing for effective solo operator training. The University of New South Wales Coal Services Mine Training Simulation Project employs a team of mining and computer engineers, computer scientists and digital artists. This cross-disciplinary team promotes a balanced development between technical detail, interactive content, and a photorealistic visual environment. After a plan of the simulation is developed in consultation with Coal Services, the model of the environment is developed by the 3D artist to match part of a real mine schematic. Equipment, vehicles, and other objects are modelled from photographs and plans. Meanwhile, the computer programmers write the simulation and the code for the many interactive choices that the trainee will be presented with. Complex atmospheric effects, physics simulations, and animated human characters are programmed, while the models and hazards and sound effects are placed within the simulation. Trainees interact with the simulation through a touchscreen and joystick interface. The choices they make are tracked, and at the conclusion of the simulation, a record of their results is saved by the operator for assessment. New simulations dealing with hazard awareness, machine no standing zones, isolation and spontaneous combustion are being developed with continuing advances in the instructional content, interactive capabilities and photorealism of the mine environment. The realism, interactivity and detail of the University of New South Wales Coal Services simulation will continue to educate trainees and help them to stay safe in the mine environment.
So, although already 9 years old, I think it's a very illustrative video. It shows the broad use of VR. So virtual reality technology also offer a good opportunity to improve and optimize typical processes in the industry. Product development can done better and faster with VR, because you don't need a real prototype or mock-up, but you get a life-size model, and the user can early in the development process see it and make a change in the model. So the consequences is a better competitiveness between businesses, firms and companies, because they can bring the product faster to the market because of less problems and mistakes in the development process of the product. So that must lead to cheaper products. So training applications are the most obvious use of VR. Here we see a video about the training application we made for Van der Lande Industries. It's a sorting machine, and workers need to practice how to use this machine. Because Van der Lande is a big international company, all over the world people need to be trained on this kind of sorting machine. It's clear that virtual training has a lot of advantages in cost and organization above a real machine. So here you see the machine in our cave. Of course the video is not in 3D, less realistic, but you see how the worker picks up balls and put them in the right basket. And there are different scenarios that have to be trained in this way. This training application of the sorting machine is complete virtual, but more training simulators are big hydraulic systems. Think about driving simulators, flight simulators, ship simulators, tank simulators, and here you see a crane simulator. And of course the army and the police also have all kinds of simulators to train the workers. So flight simulation is probably one of the oldest virtual reality applications. Flight simulators actually exist long before people were talking about virtual reality. In some way, flight simulators probably partially paved the way to the birth of virtual reality itself. Important with flight simulators is the high immersion and the real-time control by the user. Yes, perhaps simulators are the most important VR trainers currently. Yeah, the use of simulators has obvious advantages, like the cost, less material, time and money, but also less perils and less harmfulness. You can train rare and impossible situations with the simulator. You can make fast modification of the program, and also the compatibility of a program is very important. It's repeatable, and actions can be recorded and played back. So in Netherlands we have a company that makes virtual reality applications to train people how to handle with accidents.
XVR is virtual reality training software for safety and security professionals. XVR is designed to educate, train and assess the operational and tactical command levels based on predefined teaching objectives. Instructors can visualize any scenario with XVR's 3D environments and objects library. This enables you to train and assess the applicable procedures as well as the reconnaissance, analysis and decision-making capabilities of emergency responders. XVR comes with a wide range of 3D environments, which includes both generic environments and custom-made environments matching your own region. A scenario is built by placing 3D objects from XVR's library.
I think you have the idea what they make and what the meaning of this is. Here you see a surprising application, not something that you would contrive easy. Students wear a head-mounted device while suspending in a parachute harness and learn to control the movements to a series of computer scenarios, simulated scenarios. The computer receives signals from the student as they pull on the ties that control the parachute, And yeah, this saves lives and money because a plane isn't necessary. And also the environment has some benefits because no gas for jets is needed. The medicine field is one of the big players at the moment in VR. There's already about 20 years a yearly conference only about medicine and VR. Medicine Meets VR conference. It's in April 2016, Los Angeles, and here you see all the subjects of VR medicines that will be presented during this conference. Also, a lot of researchers in the medical field investigate the possibilities of VR. VR enhances the efficiency of given treatments, for example rehabilitation therapy. It helps patient move and motivate. And here you see a patient practicing his arm with instructions and feedback on the screen. Here's you see an example, another example.
Our virtual reality rehabilitation system is designed to maximally activate the mirror neuron system. Patients' real arm movements are mapped onto virtual arms in real time. If they cannot move one of their limbs due to a stroke, then the healthy limb can provide the necessary movements. Different mappings of the real to virtual arms can be implemented, for example, mirroring, following, and boosting.
So there are much more videos and examples to find on the internet about the rehabilitation therapies. A well-known and much used application of VR is to perform surgery on a remote patient. Of course, is complemented with a very precise and perfect visualization tool. Hospitals have nowadays often skill labs for their specialists. They teach here new skills in a safe and controlled environment, and of course to maintain their surgery skills. You see a beautiful picture of a body. Visualization is also used for anatomy studies and also as preparation for operations. Is this very important for specialists. So on the other side of these technical examples there are VR therapies, like the post-traumatic stress syndrome. Soldiers go back to war scenes and relive it again, but under circumstances that are controlled, and in that way they try to handle their trauma. So, especially in America, there's a lot of work done on this area. Here you see an application for obesitas, and the patient has a head-mounted device and walks through a supermarket and needs to resist the temptations that are there. A similar study like this one is performed on drugs and alcohol addiction. Participants enter a virtual world where they encounter the addictive substance as well as all kinds of environment cues. Physiological responses are recorded and analyzed in relation to the interaction of the participants with the cues and stimulus. Here you see a video on YouTube with this application.
This is me.
My DNA.
With 23andMe, find out how your genetics...
A comfortable atmosphere, the crowd unwinding with a beer. It's not real and it's not a video game. This is virtual reality therapy for alcoholics. Its aim is to mentally prepare them for situations that could trigger drinking.
If we can have a virtual scenario where we put that person in that bar or that social setting and now have the therapist be able to teach you in real time, I think that will hold up when they're out in these realistic situations in the real world, that these skills should transfer from virtual reality to their real world.
University of Houston addiction researcher Patrick Bordnick developed these virtual reality scenarios. In a study published in the journal Addictive Behaviors, Bordnick found that alcohol-dependent participants reported a greater urge to drink while viewing triggers like a bartender or a favorite cocktail, compared to viewing a neutral scene. The study even included smells.
This is the first trial to use scent. So we have computer-controlled scent. So when you walk by a shot of tequila on the bar or a beer, you automatically smell beer.
Bordnick says that realism is critical to the next step, seeing whether the scenarios can help addicts to learn coping skills.
We've demonstrated that virtual reality triggers for smoking, for cannabis, and now in this particular study for alcohol, are real enough to get real-world reactions.
He says coping with those reactions virtually could make the real world a lot less tempting. I'm Sunita Reed.
Yeah, there's very much work done nowadays with this exposure therapies. So a lot about winning the fears, like fear of high places, or fear of flying, fear of public speaking, fear of spiders. I'll show you some videos with applications. Let's see. This one. So here you see an airplane. In the middle you are in an airplane. You see the wings. You can look around. It's also somebody sitting. But you can change the environment. You can make more sounds. So start takeoff video. So that's the exposure. Maybe sea landing.
All passengers and cabin crew should now be seated with their seatbelts securely fastened. The cabin lights will remain dim for landing. All passengers and cabin crew should now be seated with
Or
their
rumble
seatbelts
sound.
securely fastened. The cabin lights will remain dim for landing.
So you can give much more exposure and try to help these people with this fear. Another one is public speaking. That's also an interesting one. Let's see. So lower the curtain. Set. So you see a room and you have to speak there. So you see a room with people and you can change their attitude. So like A gives completely static. Looking the other way with B. Bored. You can make them rude. So it's not a very interesting presentation, I think. Extremely rude. Okay, let's finish with some clapping. Thank you very much. Okay, so there are some examples for exposure therapy applications. Also worth mentioning are applications for pain control. Research found a significant pain reduction when people see during painful treatment of VR environments, especially a cold world, throwing a snowball or something like that. During changing the bandage had a lot of effect. I found an interesting YouTube video about that.
Science Central.
I was on fire. I couldn't see to unbuckle my seatbelt or open the door. I believe my guardian angel just took me out of the truck.
First Lieutenant Samuel Brown survived an attack on his Humvee in southern Afghanistan, but he would then have to endure rounds of surgery, skin grafts, and painful skin stretching.
This is a battle that's going to take years to get back to being how it was prior to this.
But while Brown's body fights that battle, virtual reality technology lets his brain enjoy hurling snowballs to the music of Paul Simon. University of Washington researchers Hunter Hoffman and David Patterson designed the virtual reality game Snow World to occupy burn patients' minds during painful wound cleaning or physical therapy.
Snow World's the opposite of fire. Snowy, cold. It's supposed to cancel out and help distract them from remembering their original injury.
Their previous research showed that not only do patients report less pain in Snow World, MRI scans show it reduces the brain's pain signals. Brown's doctors see real improvement.
What we saw was marked improvement in the range of motion that we were able to achieve, and most importantly, an increased level of comfort.
As published in the Journal of Cybertherapy and Rehabilitation, the soldiers even report a fun quotient.
I spent some time growing up out in Colorado skiing during the winters and stuff, so, you know, if anything, it sort of brings back some of those memories.
A cool escape for a war hero putting the pieces back together. Brad Closa, Science Central News.
Very good, I think. Let's look at some other application domains like factories and architecture, buildings. We earlier talked about what VR can do in the product development process. VR technology creates realistic concept representations in the early stage of the design process. And stakeholders don't only see the future product by a sketch or mock-ups, but also experience the products and the interaction with the product earlier. Another interesting example I recently heard is about setting up or changing industry halls. The factor development is with digital mockups, and designer can drag and drop with the machines, and people can walk through to see the effect of the placements of the machine. But however, if the plant is running and there should be an adjustment, for example, larger machine, then this can be entirely digital prepared. Questions can be asked like how the machine must be put in place, are there cables, cabinets, or other machines sitting in the way, what needs to be changed first. So they make a complete plan beforehand with a 3D model of the plant. Also, marketing and presentation, especially for estate agents and architects, is in this domain important. So the most obvious application of virtual reality is the so familiar architecture walkthrough. For an architect, an inside-out view of the building gives a feeling for the emotional impact of walking through the hallways in the mood of light and so on. But still, an outside-in perspective is needed to get an overall view for the efficiency of the design. So here you see a poor quality picture I made at Ballast Nedam. That's a builder's company. They have a hall with with projectors in the ceiling, and they project the ground plan of a house, of a building, on the floor. And the user here sees the house virtual. That fits, of course, with the ground plan. And he can explore a 3D scene in real time, showing exactly what the user wants to see on demand. So another person here standing on this table and can change the models here, so chair, plant, etc. And this is real-time reflected in the virtual world of the user. So So I think this application has great communication power. In VR, the user is immersed in a computer-generated world, but in telepresence, the user is immersed in a remote real world. In this case, robots are frequently used as part of a teleoperated system. Think about teleoperations in dangerous or impossible environments like Chernobyl, where they did teleoperation with VR and robots, or the US drones in war zones. They teleoperate from Las Vegas, or probes in the deep sea when somebody has to work with dangerous chemicals, and also controlling operation on a space probe. The operator is able to see and to hear with the aid of remote sensing devices and carry out the commands at a remote location. Video cameras and microphones are a substitute for the corresponding senses of the operator on remote location, and give also a first-person point of view. Note it's representing a physical world instead of a virtual one. Popular at the moment are telepresence video conferences with more and more VR technology in it. A step further are the collaborative VR/ER systems used for task performance, not only comfort during a meeting, but do something. Users can together perform evaluation sessions or to review constructions or design studies, etc. And they are in the same virtual world. Problem is during this session one person is tracked, the master user, and the others are acting as passive observers. Because the perspective is computed correctly for the master user, the perspectives of the other observers are more or less distorted, and this can lead to headaches and nausea or even sickness. And the problem becomes more severe if a master user is moving intensely in front of the screen and rotating her head very often. So to avoid distorted perspective, each user must be tracked and have its own personal perspective. Of course, this is a technological challenge, because the respective images should be projected by one pair of projectors per user and all on the same screen. So there are some limited factors like space, needing more projectors. The brightness, the light is divided in time slots over more users, and also the quality of the devices must be very high. Think about the glasses. But it would be great if several users could enjoy an undisturbed view at the same virtual world. Another method is a virtual meeting room. People meet in a neutral room by means of an avatar. They can benefit from verbal and non-verbal communication. The meeting participants' actions and words are captured and communicated by the avatar in the virtual meeting room. Yes, this is possible thanks to widespread use of both the fast internet connections and also high-performance graphic cards nowadays. Nearly each VR system can be used for this, just connected via internet. There are no special or expensive hardware needed. And users have their own perspective and can move freely within the virtual world. And they can interact where and with and what they want. So this could lead to fruitful discussion and efficient work. So there are some problems, of course, due to latency, speed of the network, packet loss, updates, and to keep the consistency in order. But there is already a lot of experience with this kind of distributed system because there exists distributed gaming. So let's look at some different VR system types. A VR system has to be minimally comprised of 3 subsystems: tracking, rendering and display. Here you see schematic the components of a VR system. There's an input and output, as we talked about earlier. And note this this computer section can be a single computer, but also a multi-pipe architecture incorporating local shared distributed memory. It can be very big. It's responsible for handling the connected devices and perform all the system calculations regarding moving, object handling, as well as graphic processing. The tracking part of a VR system can be a camera-based, magnetic, ultrasound, optical system, etc. But each of them having its own advantages and disadvantages depending on the application to be used. More about this in video lesson 4. The control device in the system is needed for the user to interact with the VR system, and can be a joystick, a trackball, a glove, 3D mouse, etc. So we talk about this part in video lesson 5. For the display projection part, there are various implementation possible, ranging from a simple PC monitor to a single multi-wall or head-mounted device, curved screens, front-back projection, active, passive stereo. Each of them offering greater or slighter immersion, and depends on the application. So there are quite different VR systems possible. Here you see a classification of VR system types. There is another one possible based on immersion level, but we use this classification. Each system has its own merits and disadvantages. The systems vary in system characteristics like resolution, perception, situation awareness, field of view, immersion, and of course price. So each system has its advantages and disadvantages, and therefore a good understanding is required of the application that the system will be used for, so that the best system can be selected for the intended purpose. Here you see some points. Point 1 is personal VR systems. Think about monitors. They are inexpensive, of course. Also called fish tanks. A fish tank. It's not very immersive because of the small view you have with this device, and it's out of date. I think nobody buys them anymore. The next is an attached head-mounted display. It rests on the user's head with the display in front of the eyes, and it moves with the user. It's a complex device, mechanically and optical and also electronical. But it's very popular because of the success of the Oculus Rift. Many other types are available. You can choose from them. The graphical hardware must be able to support 2 separate simultaneous display channels for every eye. But you have a 360 degrees view. You can look around. It's cheaper and brighter than projection-based systems, but I think it has a not to be neglected weight on your head. Projection-based displays, hemispherical displays like this one, curved screen. So those devices display in about 180 degrees field. You have a wide angle lens which distorts the output image and that's why software for spherical mapping is used to pre-distort, and then so you get an image correct on the screen again. So they are often front projected because it's also brighter. Then we have the workbenches like this one. Often they have pressure sensitive display surfaces, but there's little maneuverability with this kind of systems, so it's very static. As last, the surround systems, fully immersive systems called, like a cave. There's rear projection, of course, except for the for floors. Sometimes for the floors also rear projection because it's from below in another floor. It's expensive and you need much space for such a system. And if you come close to the display, fusing accommodation conversion becomes difficult, and the 3D disappears, and the eye strain is a problem then. Of course, the tracking is for more people a problem. So the perspective of a non-tracked person is not used, and then they have a distorted image, and also a chance on cyber sickness again. So here you see some picture of virtual reality systems. This is my first VR system, but also the power wall. There are a lot of types of power walls nowadays with not only projection but also with LEDs in it. Here you see the fish tank, the old-fashioned fish tank, Oculus Rift, of course, and the new HoloLens of Microsoft. And here you see a cave with 6 walls for projection, also a projection from below. And here's a projection screen, a power wall with a 3D with a 3D model in it. Okay, some words about a visual display. There are a number of important characteristics that must be considered. For field of regard is amount of physical space surrounding the user in which the visual images are displayed. So it's measured in a degrees of visual angle. For example, in a cylindrical display in which the user can stand, you have 360 degrees horizontal. More used is field of view. That's is the maximum number of degrees of a visual angle that can be seen instantaneously on the display. For example, a large flat projection screen is about 80 or 120 degrees. This doesn't depend on the screen resolution or aspect ratio, but how wide the screen appears to the user. So field of view varies from the user's distance from the screen. For example, if you have a triple monitor setup viewed from 5 meters away, it would appear narrower than a small single monitor that is right in front of you. In the face-to-face lessons we will look in more detail to field of view and do some calculations with it. Spatial resolution is the pixel size and is a measure of visual quality. Resolution is not equivalent to the number. Resolution depends also on the size of the screen, and the user distance to the visual display also affects the spatial resolution on perceptual level. How farther away, how high the perceptual resolution, because individual pixels aren't distinguishable anymore. This phenomenon is often a problem with head-mounted devices because the user eyes must be very close to the display screen. It's causing degradation in the perceived spatial resolution. Screen geometry. Visual displays come in a variety of different shapes. including rectangular, L-shaped, hemispherical and all kinds of hybrid forms. And non-rectangular screens shapes require non-standard projection algorithms which can affect the quality. For example, hemispherical displays can suffer from visual artifacts such as distortions at the edge of the surface, resulting in a lower overall visual quality. Light transfer, that's how light gets transferred onto the display surface. You can have front projection and rear projection, but also laser light directly projected on the retina. When using a front projected display device, realize that 3D direct manipulation techniques don't work well because the user's hands or body can get in the way of the projector, and that's causing shadows to appear on the display surface. Refresh rate, that is the speed with which a visual display refreshes the display from the frame buffer. That's not the same as frame rate, that's the speed with which images are generated by the graphical system and placed in the frame buffer. So although a graphical system could generate images at a rate higher than the refresh rate, the visual display can show them only at its refresh rate limit, and low rates smaller than 50 Hz cause flickering. The last of this slide is ergonomics. The user has to be as comfortable as possible when interacting with the 3D application. Comfort is especially important when the user has to wear the display or special glasses on his head. So projectors versus displays. So I think projectors of the near future will be more compact, more portable, and I think LEDs are replacing lamps, and also the improved efficiency will require less power and less cooling, so they will be smaller. Also higher frame rates are possible. Projectors have three distinct advantages over other displays. The size of the image is decoupled from the size of the device, so it's possible enabling a larger image from a small device. And the projected image can be overlaid on real objects, so making composition ideal for visual augmentation of real world surfaces. And the images from two or more projectors can be superimposed and visually blended together, and that's allowing configurations that improve resolution, aspect ratio and brightness. So retinal displays, here you see a picture of a virtual retinal display. It projects images direct on the retina. 3 color lasers are used. The light beams scan across the retina to place each image point, and this produces a much brighter and higher resolution image with potentially wider field of view than the screen-based display. Augmented reality display. 2 basic fusion technologies are currently being used for augmented reality. That's video mixing and optical combination. Optical combination combines the real world with computer graphics, and images are optically fused, shown as an overlay on the real world with use of a semi-transparent mirror. So you have a full resolution of the real world in this system. And the picture below is about video mixing, and it merges live record video streams with computer generated graphics and displays the result on the screen. So the real world is captured and electronically augmented with graphics and presented to the eyes. Eyes don't see the real world in this case. So both technologies have a number of advantages and disadvantages which influence the type of applications that they can be addressed to. So known problems are of course the latency and the tracking and the focus, but misalignment is, I think, the most important can a surgeon operate if the virtual cut marks are misaligned? Okay, then we go to autospherical displays. So that are displays that don't require glasses or other viewing devices. Stereo images are cut into thin slices and then alternate form a picture. And with means of a lenticular lens or parallax barriers on the top of the screen, the alternating slices can be seen by the different eyes. So as you can see on this slide. The displays are increasingly being used in small handheld devices and small TVs. And on the slide you see two types. The left is a masked type and is a kind of grating, and right one is a lens system. Realize there is always a sweet spot in front of the screen, but there are also multi-view displays possible, and they have more sweet spots. So 2 until 9 or something, depending a spot on the observer's location. So these devices use often 2D images with a depth map to create a stereo image. So here you see some pictures of workbench types. They work with mirrors, and they have a horizontal table, and people can often work together with this kind of system. So the personal station has a display on a mirror, and it has an interaction under the mirror. Optical tracking is used as input device. It's very direct and intuitive. Yeah, it's not blocking the image. In this last slide for this lesson you see some virtual reality caves. In my eyes, the summon of VR. It's an almost complete immersion system with the life-liked and the life-size models in it, and you can stand really in the virtual worlds. Important in a cave is that you see yourself, I think, because you see your own body, your own hands. It's very realistic, and the interaction is very intuitive. Today you don't need supercomputers anymore. No expensive mainframes, but a cluster of PCs with high-end graphic cards in it is enough to show high-resolution models without latency. The cave is more than a presentation environment. It is a design and communication tool, a platform for designers to communicate with each other and have interaction with virtual objects. In a cave system, multiple users can easily share the virtual environment while discussing and exchanging ideas and discoveries. However, the non-tracked users need to stay close to the tracked user to avoid receiving distorted views of the virtual scene. We talked about this earlier. The maximum number of users who could share a cave is at the moment about 5. So that's it for this. See you next lesson about human senses. Bye.